There we go. All right. Hi, I'm John, as Rich said. I'm from the University of Wisconsin-Madison. I work in the Geoscience department there. Today I'm going to be talking about all the things that basically prevent you from making a map. So you decide you want to make a map, and you go out and you find some really cool data, and then you look at it, and you're like, maybe I really don't want to make a map. So basically, things to make that process a little smoother, or in other words, why is everything going wrong? There we go, spatial data manipulation. Basically, it can include anything from normalizing your data in some way, geocoding addresses, as Rich alluded to, changing the file format to something a little bit easier to ingest, or basically whatever makes it more useful for your purpose. And oftentimes it involves those things. But before we go any further, I'd like to just mention that everything I'll be talking about deals specifically with vector data, so line, points, polygons, that kind of stuff, not raster data. So like if you were to go fetch satellite imagery or something, that process is quite a bit different. So I'm just going to be focusing on vector data for now. But there's a lot of file formats you're going to come into contact with when you go searching for data. These are the main ones that you're going to encounter. The shapefile is kind of the standard for geographic data. It's not a very good file format. It's kind of clunky to work with and has a lot of things that don't make it very pleasant, but it's a standard. KML, which is kind of nice. It's from Google. Allows you can just drop it into Google Earth. It's the format that Google Earth likes to use. GeoJSON's a little less common if you're searching like government open data portals or anything, but it works really nicely in a web environment. In CSVs and geodatabases. Geodatabases aren't as common, but sometimes you'll see them from government agencies as well because it's a format that they have to store their data in. And all these are fairly easy to work with. There's a lot of documentation and tools to work with them. They're not that bad. It gets a little bit trickier when you come into contact with these. Like I've come across ones where someone will publish like a chart or a table of data in a PDF, which if you know anything about PDFs, that does you absolutely no good because it's no longer text. Sometimes you can extract it out of there, but oftentimes not. It really depends. I've gone through and manually cleaned up data from those before, and it's not fun. Excel spreadsheets are also common. Those can really be in a lot of different levels of quality. Sometimes they're really nice and formatted nicely, and other times there's all sorts of other stuff and calculations going on in there that can get a bit messy. The one that I think a lot of people don't initially go to but is really useful are, as Rich talked about, APIs, but in this case we're talking about streams of data over HTTP. A lot of people are starting to put data out this way, so it's not the type of thing where you can just go to one place and download a file. You hit a URL specifying some query parameters and it'll spit back data. So oftentimes when you're working with these, you'll write a little script to go through and grab all the data that you need and save it to a file, or you may just build an application on top of that and hit the API directly. One of the big things you're shooting for, no matter what your end purpose is clean and compact data. No matter what you're doing, you don't want things to be messy. You don't want it to be more verbose than you need it to be. Getting it into a format that you'd be okay sharing it with someone else. There's a lot of things that make this a lot easier for you, which is basically your toolbox. It's just like fixing a bike. If you have the right tools, it's really easy. If you don't, it's not fun at all. The big one that underlies most geographic software is called GDAL. GDAL is the raster manipulation chunk of it. OGR, which is the vector version. They come in one package though. It's a command line tool, but it underlies things like QGIS, PostGIS, basically any geographic data application. Another one that Mike's going to be talking about is QGIS. It's a desktop GIS package. If you've worked with ArcGIS, it'll be very familiar and comfortable to you. Just as powerful in most ways and more useful in a lot of others. And something else that I think gets glossed over a lot of the time is just having these two things properly installed on your computer. No matter what, that's the thing with a lot of these. Once they're installed properly on your computer, it's a breeze, but a lot of people don't get over the hurdle of actually getting things properly installed. And that's oftentimes the hard part, which is unfortunate. But if you have a properly set up Python installation, which no matter what platform you're on, you should probably have it, your life will be a lot easier because a lot of geographic tools are written in Python because it's the interface to ArcGIS and QGIS. Node is JavaScript runtime on the command line, and there's also more and more tools written in Node. It's really easy to install on most platforms, so you should just do it. It just comes as a package installer. It's easy. While I'm on that topic, don't be scared of doing stuff on the command line. I know a lot of people's first tendency is to open up a desktop application and do everything in there, which if you just needed to do something one-off, that can be very useful, but oftentimes if you need to process a lot of data, or if you need to go through it many times, iterate on it, it's a lot easier if you can just write a script to do it for you. So it makes your process a lot more repeatable, easier to share with people, and if you need to go back to it in a month, you don't have to remember which buttons you clicked in which order, you can just run a script and you're good. So I'm going to walk you through a couple quick examples of common tasks you may want to do. The first one is just reprojecting a shapefile. So for example, it's a link to the Kentucky Senate districts. Let's say you want to make a map of election results or something, and you have a spreadsheet of the counts in each county or in each Senate district, and so you go and find a shapefile of the geometry. But then you download it and you see that the projection is NAT 83 state plane Kentucky statewide 2001 FIPS 1600, which is meaningless and you don't want that for anything ever. So you can use a simple tool like ogre to ogre from the command line and run one simple command and you have it in WGS 84, which will be able to play nicely with most of your other things. If you want to add other data to it, combine it with something else, export it to make a web map, it's a lot easier, and you don't have to open a program. It's just the name of the command, the output name of the file, your target spatial reference system, which is EPSG 4326, and the name of the input file. So it's actually pretty straightforward, nothing real complicated. But let's say you want to make a web map out of this then. You can just modify it just a little bit, and it spits out a GeoJSON. So you just went from some projection that you're never going to find any other data to work with to something that you can use anywhere. And then once it's in a GeoJSON, all I did was copy and paste it into GitHub gist, and you have a little interactive map. Another example, joining attributes. So for example, if you went to Natural Earth Data, which is a great website if you've never been there, really nice line work for a lot of different things. And you download the different states in the United States. And then you went to the CDC's website and you found a spreadsheet of diabetes estimates for each state. And you wanted to make a map of diabetes rates across the United States. There's an ogre command you can use to do that too. You can do this in a lot of different ways. You can do it in QGIS, ArcGIS, PostGIS. You can also do it on the command line fairly easily. And to walk you through this one, you're using ogre to ogre again. You're using the SQL bit of it, which is structured query language. So you're basically just running a query on two different data files, right? And so you're selecting everything from both of those, and then you're joining them on the name property of the shapefile and the state property of the spreadsheet. Another common task, if you're doing anything but surveying data, is to generalize your data in some way, especially if you're working with polygons. And a great tool for that is mapshaper.org. It's a nice little interface, so you can go, let's use the Kentucky Senate districts we got before, and you get a nice little map. And then what you can do is simplify the geometry very easily, the different thresholds. And so, especially if you're viewing data at a smaller scale, it can be very useful to do this because it shrinks the size of your data a lot. It makes it look nicer. but it can really, really shrink your file size a lot. So for example, what that percentage in the corner up there is the number of original vertices preserved. So at this scale, you can go down to, I don't know, what do you think? Like, there you start seeing it a little bit of loss. So you're only preserving 5% of the original vertices, and you really can't see a visual difference at all there. Which is kind of cool. But I mean, if you're working at a larger scale, you can see that maybe around there, 30%, 25%, you start to lose some detail there. So I mean, it really depends on your purpose, but if you're doing something like just showing a statewide map of Kentucky Senate districts, you don't need a lot of detail for that, you know. You can simplify it down and still preserve the same idea. So that's a great tool to use for almost every project you're using. It's fantastic. And again, you can actually do this with Ogre to Ogre too. You can use QGIS for it, PostGIS. A lot of other things will do this, but I really like to use MapShaper because it gives you a visual guide as to how much simplification you really need. Because with those, you're usually specifying like a simplifying tolerance, and you're just, I don't know, at least I'm just guessing what it is, and it's guess and check. With this, you can actually see it. And then you can export it to a shapefile JSON or TOPO.json file where you add it too. So it's your conversion as well, which is kind of nice. And then the example, last one that Rich was getting into a little bit, or one that we're being a little continuous with, Lexington restaurant data. When you go to their website, as Rich showed, you get this Excel spreadsheet of the data. And you have addresses, and you also have 270 extra columns that you don't need for some reason. They're there. So as a first step, if all you do is save this as a CSV and don't do anything else, you reduce the file size from 4.2 megabytes to 1.1. And then if you actually delete all the excessive columns, you're down to like 300 kilobytes. And you haven't lost any data whatsoever. But something kind of interesting about this that you don't initially see is that each row is not a unique place. Each row is really a unique place, date, and type combination. So depending on how you want to visualize this data, you may want to just keep it as a spreadsheet like this. But you may also want to represent it as a one-to-many relationship as it is. So each restaurant is a place, and then an inspection is actually an attribute of the restaurant, right? So there's a file in the repository for this that you can see where I translate it to that format. So basically, instead of each row being a unique combo and representing a lot of this data multiple times, like for that first one, you can see number 1 China Buffet. You don't need to represent that address 3 times or its opening date 3 times. You can do that once and then just have all the inspection-specific data be there. So it's restaurant and then all those attributes that are common across all, and then inspections, which is an array basically of different inspections. And another thing is, this is what it looks like if you open an Excel spreadsheet in a text editor. That's another reason not to use Excel spreadsheets is if something happens to them, you're kind of out of luck. You can't really do anything with that data. But if you just save it as a CSV instead, assuming you don't need to use any equations or anything in it, it's actually human readable. You can actually do something with that. There's also a script in that repository. I won't get into too much detail with it, but it's just a short little Python script to go through that data and actually assign a lat long to each address. And so all you're really doing is stepping through, grabbing an address, passing it to a geocoding API from Google, and it's spitting back a lat long, you're storing that. And so this is what it looks like when you geocode it. You just geocode it, open this in QGIS, and you're a lot closer to actually making a map, which is kind of cool. If you want to see any of this code that I use to geocode anything, restructure that CSV as a GeoJSON or anything, you can find it all at that link too, and all the slides as well. It's CC0, so feel free to do whatever you want with it.
Cool.
So, yeah.
Thanks, John.
Thanks.